Hello, welcome back to Monster Frequency with me, Ben, here. It's Earth Day. We've got a very special episode today. I'm absolutely delighted to be joined by Professor Michael Sweet from the University of Derby. Now, he's a very modest man, but he truly is a pioneer when it comes to the science involved with coral reefs and the impacts of environmental change on coral reef ecosystems. Now, his impacts have gone way beyond actually his own kind of personal science, some of which actually has looked into the microbiome and kind of how this plays a role in disease and the kind of wellness of coral reefs. But it's also extended in a bit of a different way because he's also worked on the kind of science and culturing of coral reefs, which has really assisted, in countless research streams through bringing the coral reef as a study organism in labs all around the country. As a bit of context, it's typically, traditionally been very difficult to grow corals, for use for research purposes. So this is kind of one area that he's had a massive impact and continues to have a massive impact. So we got talking all about this because on Earth Day, of course, it's a good time to reflect on the natural environment, the Earth. I thought this is a brilliant person to talk to, Prof Michael Sweet, today, because we're probably all aware of the quite shocking degradation and damage that we've seen occurring to reefs worldwide. The Great Barrier Reef is, probably the most famous example, and we've probably all seen those images of widespread coral bleaching and the kind of, untold consequences of that for the wider environment. So we kind of get talking a bit about this. We get talking a bit about environmental science in general, a bit about ocean optimism, about things that we can do to potentially help a little bit, and I guess about the kind of problems in general that the environment is faced with. So I thought, perfect discussion for Earth Day. So this is all from actually a recent chat I had with Mike. Now, he agreed to return, actually chat to me on the radio as well, and be a guest on Monster Frequency. So I am really, really, really very pleased to invite you to Monster Frequency, Prof Sweet. I hope we can have you again on here in the very near future. I'm sure we will. What about next Earth Day? Yeah? Back again? Hope so. Anyway, that's enough from me. I'm going to let him introduce himself, say a few words about his position. And yeah, then we'll get chatting all about coral reef ecosystems and the wider environment. So here he is.
My name is Michael Sweet. I'm a professor of molecular ecology at the University of Derby, and I'm head of the aquatic research facility at the university. We work on a whole heap of different research projects, from coral research to shark biology.
Oh, Michael, well, thank you very much indeed. It's a very, very warm welcome to you. I can remember actually last time we were chatting, I actually caught you after a seminar that you delivered at the Environment and Sustainability Institute a few years ago, and I can remember just being absolutely blown away by kind of thinking about, because I was used to kind of thinking about, coral reefs and the kind of symbiosis, but I can remember my mind just being completely open to all these other interactions that were going on, and I was just really hoping you could kind of talk a little bit about that again, and kind of this idea of the microbiome. I think it's just absolutely fascinating that there is just so many interactions to think about, isn't there?
Yeah, so I sort of refer to it as like the sort of Serengeti to get students excited in it. Most biology students and zoology students are really keen to see those larger mammals, elephants and giraffes roaming the plains. But if you actually look at any organism, you can, and under minute detail, under a microscope, you see a whole world and a whole interaction of different species, different organisms, different groups, different kingdoms, all interacting together, predators, prey, parasites, and it's a fascinating world to really explore, from bacteria and viruses to the bigger predators like ciliates and other protozoans.
Yeah, it's fantastic. I think, as you say, that kind of thought in general about kind of exploring it is just absolutely fascinating. I think it really goes for kind of anyone listening in as well. Because it just from a layperson's perspective, they can think about, perhaps, as you say, the kind of super charismatic kind of examples of species, and then actually delve a bit further. And I think the microbiome, because I don't know about yourself, but I think people are hearing more and more about that, aren't they? I think it's something that's being explored a lot more and more in recent years, and it's just really interesting to kind of think about that applied to areas which perhaps people haven't really thought about before, like corals, for example.
Yeah, so the microbiomes are important for everybody. Yeah, we all have our own microbiomes, and interestingly, the human microbiome, so things like the gut microbiome, which keeps you healthy, that's about 90% of what makes a human is not human cells. It's the other things. So that little fact on its own, that little factoid, shows how important these different species which make up the microbiome actually are. And it's important for health. It's also important for disease and so on and so forth. It keeps you thin. It makes you fat. It makes you run well. It makes you everything and anything is governed by these microbes. And if you take that from a human, obviously to keep us healthy, it's exactly the same application to a coral. It's what makes a coral tick. It needs these individual microbes, these core microbes, these stable microbes to make them healthy. And any disruption of that is called, it moves us on from the microbiome to what's called the pathobiome. So patho being disease and pathology. And a shift in the microbiome has been documented very well to highlight that this is the sort of first stage and onset, and sometimes an early warning indication that something's not right and a disease is going to kick in, and then you'll start seeing the physical signs of that. So it's like an early warning system, and managers and scientists and conservationists can tap into this early warning system to give us an understanding to maybe try and do something about it. So we actually explore the wonderful world of probiotics now. So this is the use of good bacteria to try and fight off those nasty ones.
Yeah, thank you, Michael. That's absolutely fantastic. Because I think in some of your recent published work that I've just been having a very kind of brief look, and obviously a complete kind of non-expert here talking about this, but just fascinating to see that you've actually been working on kind of this whole kind of suite of loads and loads of different kind of culturable bacteria, and you've kind of been looking at the potential applications of those, as you're saying, in kind of coral health and things like that. And I think that's just a fascinating thing, because I'm sure people have kind of heard about this idea about, obviously the algal symbionts in the coral and work that kind of looks at teasing those apart and looking at different strains, and there might be kind of thermally tolerant strains and things like that. But I think it's really fascinating to think of actually the microbiome and being able to kind of manipulate that as well. It's just fascinating.
Yeah, so the culturing of bacteria in this instance, but we're also looking at things like fungi as well. The world of fungi is very unknown in marine biology, but fascinating to me, and it's something we're delving into quite in depth at the moment. But most people look at the bacteria at the moment. It's the sort of next thing, as you mentioned, about the symbiotic algae, and then bacteria is the next member of the microbiome, which is more commonly looked at. And culturing is not a new thing. It's something which has been done for many years. And in fact, back in the sort of 1980s, it was more extensively done. Now we sort of rely a little bit more on the super fancy techniques like next generation sequencing to explore the metagenome of these different organisms, which gives us a really fascinating insight. But we lost our way a little bit, and we forgot to actually look back and understand what we could culture in various labs, what those organisms can then do, how can we manipulate them to assist in things like restoration and conservation practices. So we've sort of reverted back to these relatively simple techniques of culturing organisms. We advance them. We modify the culture media to try and increase what's called the un-culturable fraction. There's thought to be almost 99% of bacteria thought to be unculturable because they're reliant on a host or reliant on something that we just don't quite understand at the moment. We think we've actually knocked that back a little bit already, and in some cases we've got some preliminary evidence to suggest that we can culture up to 80% of some corals' microbiome. But that's still work in progress. But it gives us this whole suite of different things. And one of our probiotics studies, so we've done proof of concepts of using probiotics, these good bacteria, with a simple application of 6 good bacteria to a coral. We've shown that the coral can actually withstand higher temperatures. It can not only weather bleaching, but it can also fight off diseases. And this is just the inoculation of 6 lonely little bacteria onto a coral, showing the great promise that these individual members play in this whole microbial soup, which is the coral's faces and is exposed to on a daily basis.
Oh, it just sounds awesome. I mean, I'm sure this is kind of a bit of a naive kind of comparison, but as you're kind of talking about those kind of previously perhaps thought of as un-culturable microbes and kind of being able to explore those further, it reminds me straight away actually of the kind of, we're always thinking about undiscovered species in the rainforest and thinking about, potentially beneficial products and things that we can actually, extract almost from life in that way. It kind of made me think about that, like almost likening it to this rainforest of kind of undiscovered opportunity. I think it's really fascinating.
Well, 100%, and in fact, we've actually we will work on this aspect as well to a degree. So it's actually referred to in the trade, let's say, as blue gold. So this opportunity for biotechnology and bioinnovation to come from just understanding and exploring the microbes, especially associated with symbiosis and especially associated with corals and sponges and things like that. It offers up a whole new world of different species, novel antimicrobial aspects, which can be harnessed for the greater good.
Yeah, that's absolutely awesome. Because I know you got the kind of innovation angle there was actually something that I can remember very fondly. Actually, last time I was chatting with my colleague Sam for the radio. Last time you very kindly agreed to appear on the show with us, and I remember you were talking a bit about the kind of that textbook that you'd written, Introduction to Molecular Ecology. And you kind of tried to kind of define this kind of area, and actually there was a lot of kind of aspects of that really sounded like pretty sci-fi, to be honest. I mean, there's a lot of innovation to be had, I think, in this kind of crossover area, isn't there? I mean, you were talking about things like, eDNA and kind of the kind of scanning capabilities of that you can imagine, coming in the near future, and de-extinction, all these kind of terms that just sound like they're fresh out of a sci-fi film. But I just think it's amazing to think that actually that those kind of things really aren't too far out the world of actual real science, are they? It's amazing.
Yeah, well, there's some fascinating like memes and things like that which I use in my teaching, where to the point we can even technically recreate things like Jurassic Park. So science says we can, ethics says we might not. We might not necessarily need to go down that route. Like, yes. Should we bring back the woolly mammoth or maybe the thylacine or something along these lines? And it's really there. But you touch on the idea of sort of bioinnovation and the aspect around that, the commercialization side of things. Quite a few scientists sort of shy away from commercialization, but I think it's quite an important thing to highlight, both to students who are coming into this field, because not everybody's going to go into the academic realm, and in fact the actual figures associated with how many PhD students get a permanent academic role is actually ridiculously low. It's around sort of 3% or so. So a lot of these highly qualified students are moving into other fields, and the commercial field is one of these key aspects. And we work quite tightly with various commercial companies. In fact, we actually run a company ourselves, and it's this balance between science and commercialization, which I think actually advances many of the fields. And it brings money in, and it also creates other opportunities for students to learn and to advance science in many different ways.
Yeah, thank you, Michael. That's fantastic. It's kind of got me thinking about, I think it's kind of one of your other hats really is the kind of founding the coral spawning lab, I believe, because I think that's kind of where you're basically advancing. You kind of talked about this earlier, I guess, with the kind of culturally kind of isolating those bacteria and kind of growing them and increasing the number that can actually be utilized in that way. But also, I suppose, you kind of other aspect that you've been doing is, of course, on the coral side, isn't it, with the coral spawning lab? I thought that sounded really cool.
Yeah, so so I'm obviously a scientist, and that's where my passion is, and my passion is to answer the unknowns. Usually, if someone comes to me and says, what's this, or how do we do this, I first obviously go in and see if it's been done before, and if it hasn't, then I get excited and start delving into it. And one of the things that so our story with the coral spawning lab started during my PhD a long time ago, between 2007 and 2011. And I was working tightly with some aquariums, particularly down in London, the Horniman Museum, and a colleague of mine, Jamie Craigs, and we were looking at diseases in aquariums. So it was a really easy way. But we were using a lot of corals, and we were killing a lot of corals, intentionally and unintentionally in many instances. And we collectively thought, right, okay, how can we stop this? We don't want to be killing things, we want to be protecting them and saving them. We use that for science to advance the disease research, but then we focused on what makes a healthy coral tick. And then when we were looking at what makes a healthy coral tick, we were like, well, one of the key aspects of that is to breed from them. That's what zoos and aquariums do, and sometimes very, very, very effectively. And having this breeding program would be very useful and very important. We could change the world just in the aquarium aspects by meaning that there'd be no more collections needed for aquariums around the world. We could be self-sufficient. We could be sustainable. We could eventually, possibly even start repopulating reefs if it was all done properly. So if it was all done in a nice, sensible, sterile way, specific countries working with specific countries, so on and so forth. Don't need to get into that. But the sort of concepts were around that healthy organism. So spawning corals made a lot of sense. So we tweaked and changed, and we did a lot of various different projects to get that understanding. And we cracked it quite early on, and we were the first people to do ex situ spawning. So not only were we spawning corals away from the reef, but we were doing it in London and in Derby, in the middle of nowhere, nowhere near any of these tropical reefs. And it was all down, well, I say all down to, there was a lot of husbandry associated with it, but it was down to the environmental parameters, the sun, the moon, the water temperature, feeding the corals, all these different elements which needed to be brought into play to allow our corals to spawn. And a lot of knowledge, obviously. And then once we started pushing out these papers with the science on the how, many people wanted to say, well, can you help us? Can we do this?
Yeah, sure.
And as scientists, we were like, yep, sure. And we helped. And then it turned into a full-time job, helping this, helping that, helping that person. So we suddenly thought, right, okay, well, maybe we should commercialize it. And we worked with an engineer and a designer of aquariums to build these systems, which the Coral Spawning Lab now offer. And they're sold all around the world. We've sold 34, which have been shipped out. More are being developed all the time. These are in places like Saudi Arabia, in KAUST, the King Abdullah University of Science and Technology, in Moat Marine Lab in Florida, in Oldenburg in Germany, in Lisbon, in the ocean area. So different people are using it for different things. You've got aquariums using it for science and outreach and to maintain their own stocks. You've got scientists who are increasing the amount of spawning periods you can have, because now you can spawn corals all year round if you so wish, instead of waiting for that one natural spawning system. And so from a science side of things, you can manipulate it so that you have these regular spawning events, and they're timed as well. You can change them during the day as well, instead of waiting at night. Normally they spawn a few hours after full moon, so we can make it a bit more convenient for the people working on that. And so you sat there with your cup of tea instead of your beer now, watching these corals spawn, and that means that these scientists have these extra products, let's say, these different larvae, and you can do different mixes and things. You can do sort of interbreeding, and it means that their time is more efficient. So they're not waiting for a year. If something didn't work and they had to wait another year, that's very inefficient. Now we can advance the field so much more by giving people the opportunity to work with this thing which was only once a year, and now it's available almost on demand, basically.
Yeah, that's crazy, to be honest. I mean, I guess people listening in will probably find it pretty obvious from what you're saying, but obviously it's absolutely no easy feat at all, is it, actually culturing these organisms? I mean, I've got some limited kind of culturing experience myself, not with corals, but with other kind of lab organisms, and actually even the kind of day-to-day run-of-the-mill lab organisms can be fairly complicated to keep kind of alive and healthy, and I just think, removing those kind of barriers, because it's quite clearly a big barrier to research, isn't it? Actually getting hold of the appropriate study organism at the appropriate time, as you're saying, and getting hold of those corals. That sounds like an incredibly valuable tool, actually, for science in general.
Yeah, there's still issues. We still get the odd disease outbreak coming in unexplained, and because it's in the science, and because we have this network of people now, so all around the world, we're starting to do larger scale collaborative projects, gathering all this information and really understanding what stuff which we couldn't necessarily have just done individually, and we can work as a big network, as a big team, to understand why does the ex situ corals seem to spawn a few days after the wild spawn. So it seems that we sort of saw it quite regularly, that it was 3 to 4 days after the normal natural spawning, and we didn't understand why. And our systems were synced specifically to the field, but it was time and time again. And so now we've got those systems all around the world. We can start to really design the research to try and unpick that. Why does it matter? Does it matter? Or why? And if so, what can we do to alter it and change it? And also things like disease outbreaks still come in. There's some theories about that, and trying to unpick and untangle that as well, to see if we can cure that. And it might be a probiotic approach. So we might be combining our science again with a commercial application to look into developing probiotics which can be used by anybody and everybody, from the hobbyist to the scientist, to improve the health of their corals.
Oh, that's fantastic. I mean, I guess kind of in the same vein as the kind of thinking about the kind of sci-fi elements. So if you'll allow me to kind of get a bit silly and kind of think towards the future, but to me, it actually does really sound like we're almost on the cusp of like something really exciting here, because obviously, being able to manipulate both the easily culture, well, I say easily, but being able to culture the corals and the different strains, and kind of having manipulation powers over them that way, but also being able to delve into the microbiome and grow particular species and kind of combining them in that way. It kind of sounds like, merging those two kind of areas, it kind of sounds like you've got a lot of kind of power to kind of pick and choose these various combinations that you could explore, and potentially even, as you were saying kind of earlier, like repopulation. If you could work out what would, what's the perfect mix, I guess like some kind of Goldilocks zone, you could get there, with these kind of tools. I think it's amazing. If you allow me to get a bit silly.
Yeah, it's definitely in reach, and in fact, in the media, the term sort of super coral has been bandied around. Most scientists don't necessarily like it, because it sort of gives the impression that, oh, it's okay, we'll just breed these super corals which will be more thermotolerant or more disease tolerant. But the actual science is that we can. Whether we can do it on large scales is still a big question, and scalability is something that we are looking into. And if our systems from the company go all around the world, which is the goal, then that scalability gets chipped away at a little bit. And if everybody who wants one has these systems or has multiple systems, then that restoration element can take hold. But in the lab, we have been able to cross corals from Australia and Singapore, for example. And just to give you a sort of understanding of that, in Australia, most of the corals will spawn in sort of November, September. In Singapore, the same sort of species or the same genres will spawn in March, April. So we synced the spawning of those two different groups of corals from two different geographical locations, and we could create geographical hybrids, and we could also create species hybrids. So two similar acroporid species spawning together. We mix them together in a sort of artificial insemination approach, and lo and behold, you get this hybrid coral. Does that hybrid coral then offer certain advantages? Does it have trade-offs? So on and so forth. These are all the questions which scientists around the world are now able to address and answer because of the technology we've provided them.
That's absolutely fantastic. I mean, I think if you'd allow me to use a daft term, I think you're giving me some kind of coral optimism here, because obviously I think for the kind of layperson, it kind of sounds pretty doomed almost, the kind of coral ecosystems, and obviously, as you're saying, this progress in this area doesn't mean that we no longer have to think about limiting, obviously, the damage that we're causing to corals, but it does sound like we're actually making amazing progress, towards potentially safeguarding them for the future, which I think is amazing. I think that there is some optimism to be had there. I think I don't know what you would kind of think on that.
I love a bit of ocean optimism, but I don't want to necessarily burst your bubble and also sugarcoat it too much because sadly with climate change as it is, reefs are in dire need. The Great Barrier Reef at the moment is undergoing another mass bleaching event, unprecedented repeat bleaching, and no matter what we do, so I see these things like the probiotics, the coral spawning, as sort of sticky plasters. Maybe it'll give us a bit of time. Maybe it'll give us a few years. Maybe it'll give us 10 years. Maybe it'll give us 30 years extra time. Who knows? Maybe we'll end up with various different ark sites around the globe. So in the Caribbean, for example, Florida Aquarium, who's using our systems, have built a sort of ark for the Caribbean, for the corals off Florida, the Florida reef tract for the Caribbean corals, because they've got this disease called the stony coral tissue loss disease, which is wiping out huge numbers of their remaining corals, and they didn't have that many remaining corals in the first place. So they got to the last ditch attempt where they were taking them out and having this breeding stock, with the possibility that if the environment gets reverted back to some sort of normality, then they'll have the stock to rebuild and re-establish reefs. But that's a mammoth task. That's not anything to be understated, really, and will cost a lot of money to maintain. We'll use a lot of skills and knowledge to keep them healthy and not lose those populations, as all zoos and aquariums do. But it is only a stopgap, because always the goal for these conservation programs is for them to be reintroduced into the wild. And if we don't tackle climate change, then there won't be anything to reintroduce them to. Even if we build supercorals, those supercorals are only going to be few and far between. And what many people don't quite understand is when scientists say coral reefs are in danger, they don't mean corals in completeness will disappear and go. There'll be some species which are more tolerant and able to adapt and change. They're sometimes referred to as weedy corals. So the actual coral, the calcifying animal, will probably outlive all of us humans. But reefs themselves, these massive diverse structures, reefs are home to upwards of 30% of all marine life. So just imagine that. If you lose that reef, you lose 30% of all marine life. That doesn't bear thinking about. And that is what is in danger. This massive full-on rugose, this 3D structured, continually calcifying habitat, full of diversity, full of thousands and thousands and thousands of different species: fish, urchins, corals themselves, sponges, algae, It's like the rainforests of the sea. They are the rainforest of the sea, and we are boiling them with our carbon footprint. And I see on Twitter and on various different social media platforms, obviously everybody arguing between, it's the government's responsibility, it's the individual's responsibility. It's everybody's responsibility. We all need to do our bit. And if we're not doing our bit, then we're just sitting and watching the world burn.
Yeah, I think that's a really, really, even if people go away today with just one thought, I think the kind of reiteration of how absolutely vital that is, it could be a really critical takeaway. And I think when people are kind of thinking about all the kind of really fascinating kind of breakthroughs in the technology and the science that you've kind of been talking about, I think really that's strongly caveated, isn't it, with that sense of urgency about the protection of corals and indeed the wider kind of marine environment. I think that's a really, really good takeaway for people today. So thank you, Michael.
No, you just need that balance, and it's something I've contemplated in my own living and things like that. Like, do we have a car? Yes, because we need to take my son to nursery and so on and so forth. At the moment, I can't pop him on a bike all the time, but I used to bike. So have to have one of those evil gas-guzzling cars. Can I shift to electric? Yeah, but not at the moment because they're too expensive and they don't tow a horse because we've got a horse. Sure. Do we need a horse? Probably not, but it's one of those life options. Same with things like heat pumps. We just recently had an extension on our house, and I looked to get a heat pump put in instead of the gas boiler. It turned out to be ridiculously expensive to put in a heat pump. It's not quite ready yet. Now we're moving that way, and the government's moving that way. So it's this combination between individuals knowing and understanding and choosing things, but then the government making those options an easier choice. So make those electric cars cheaper, make those heat pumps a better option rather than putting in a gas. Not better just for the environment, because that's a given, but better or at least equal to the current options which are given to us by various different people. So it's a tricky thing. If it was an easy thing, everybody would be doing it.
Yeah, sure.
But you have to just do your bit, like order your coffee with a reusable cup, and go for a walk instead of driving if you're going to somewhere which is 5, 10, 15, 20 minutes away or whatever. It's those little things which all build up. And if everybody in the world was doing all these little things, then we would make a massive difference. We don't need to necessarily wait for the government to actually make these big changes. But then my call to the government is make the big changes as well.
Yes, of course. Yeah, and I know that's a really nice point, actually. It's almost kind of just trying to think of like a way to it's almost like a willingness to kind of accept, isn't it? A willingness to adopt kind of slightly better options for the environment, even if that feels to the individual like it's a really minor thing, as you're saying. Multiplying that, obviously, you're making a big difference overall. I think it's like a willingness to adopt it, and as you say, the government hopefully continuing to actually make those choices slightly easier for people too. I think
it's like a chicken and an egg thing. Like everybody's waiting for someone to make the first move, and the government won't necessarily ban diesel cars until people are not buying diesel cars anymore and moving towards electrics and things. So it's very difficult from a politician's point of view and from the general public's point of view about who's going to make what decision first. There isn't one answer, and I see that across all these social media platforms, people saying, "Oh, it has to be the government," and it's like, well, no, not necessarily. And then other people are saying it has to be individuals making the decision. And it's like, no, but maybe. It's not a straight answer. And as scientists, we love a straight answer. We love a sort of black and white, but the answer is it's grey and muddled and in between. And I find that quite exciting. Like I was talking to some students the other day, and I was saying that coral reefs are actually the science suggests that coral reefs are going to be functionally extinct, basically, not working as they should by 2030. In 8 years, coral reefs around the world will be functionally extinct.
Yeah, that's
that doesn't mean that the corals will be dead. It just means that they won't be doing what they're supposed to be doing. And some people say by 2050, pretty much every reef will be completely degraded and past hope. And that is looking very likely. And so when I was saying this to the students were like, so we shouldn't be a coral biologist. And I was like, no, that's not what I meant. I don't think... Yes, we've got this sort of finite period of time, this 8 years where we can see reefs as the beauty they are. And you can go and find a beautiful reef to dive on and see the diversity, and it's fantastic and amazing. But it's on the horizon of complete catastrophe and collapse. And I find that fascinating as a scientist, because there's all these weird and wonderful things, these interactions happening and these cause and effects to study, and then these possible solutions which we've talked about. But it's also saddening in the same breadth, because you're witnessing the death of an entire ecosystem and certain species and species extinction and things. But we can do something about it, or at least we could try. And that's the education part of what I do. Is I really try and inspire and teach people that there is that hope, there is that ocean optimism, not to be taken lightly, but to be grasped and embraced. And it's the younger generation. We always put it onto the younger generations, but it is the younger generations who will be the next people to come up with that hopefully world-changing idea, which will take us into the future in a nice environment.
Yeah, thanks so much, Mark. Because I was actually thinking that a kind of really nice place to kind of head towards closing up would be exactly that, talking about kind of the kind of education side to your work, and thinking about, because I was going to ask really if there's anything that you could kind of, I don't know, suggest for people out there, it could be students, but also just the kind of general public, if there's any places that they could go, that you might suggest them, like it could be your lab websites, or I know you tweet out from your handle Disease Matters, things like that. Just thinking of anything like that people could get involved with, have a look at, and kind of stay up to date, have a think about, what we've been talking about today, and obviously as well thinking about, the environment and what they can be doing, anything like that really. I was just thinking about just giving you a bit of an open platform just to say, check this out or check this out. I don't know what you think, but might be difficult off the top of your heads, but if you've got any ideas.
Well, there's different platforms for different people. I still really love watching a David Attenborough documentary. It was what originally inspired me way back when, and watching things like The Green Planet and stuff like that. I'm a zoologist and a biologist. I work mostly in the marine biome, but I'm fascinated by rainforests and shrubland and deserts and everything. And it's just nature, and it really just gets me. I just love it. I walk my dogs, but I keep them under control to make sure that they're not causing any damage or anything along those lines. And it's those nature documentaries which first inspired me. So I've got a young son, Isaac, who's 20 months, and I'm starting to introduce him to these sort of things.
Oh, fantastic.
It's going out to nature and appreciating it. There's an old adage which is where you only conserve what you understand or what you know. So if you don't understand that cutting your hedge back in the middle of spring or late spring when birds are starting to look for nesting is a bad idea, you might be cutting your hedge back any time of the year. And you're disturbing breeding birds and possibly impacting the egg laying or even the juveniles. But if you don't know that, you can't be held responsible for that. And it's just getting that science out there. So it's doing things like talking to yourself. We do a lot with various different schools. We're going to host for Science Week and part of the British Science Association. We're hosting some people who won an award for writing an essay to come and stay at the university for a day, learn what it's like to be a scientist. We obviously have undergrads and master's students. We have those websites. We do blog posts. We do Twitter, as you said, with at Disease Matters. And it's just getting that information out there in various different media platforms. Things like the film Chasing Coral. It's not everybody's cup of tea, but it did its job. It got people, that's available on Netflix, it got people interested and looking and going, ooh, something's happening out there. So it's just finding what resonates with you. But I've started recently working with a lot of psychologists, and one of the most interesting things I'm finding is this thing called a value-action gap. So it's a psychological term, and this is quite a nice ending point. But what it does is it highlights people's connections with nature. So people's interest in conservation behaviours or anything along those lines. So it could be something as simple as recycling, or it could be planting trees, or keeping your dogs under control when you're walking in a nature park or what have you. It's that link to nature. We want people to go out and enjoy it, but we want them to do it in a nice, sustainable way. So leave only footprints, don't leave your litter and all those sort of things. And this psychology behind that is very interesting. So what people found with this value action gap in a study which looked over the whole of the UK was that only 30% of people in the UK cared about nature, so wanted to do something. And only 10% of that actually did something. So actually got up and did something, drove their car less, rode a bike instead, planted the trees, whatever. And so that means the value action gap means we can target, as scientists, conservationists, as NGOs, as the government, as council members, we can target that extra 20% and make people's behaviour proactive for these ecological behaviours, these beneficial behaviours for the ecology and the environment. So that hits us 30%, which is great. The sad somber part of that is that 70% of people still don't seem to care. And we could chip away at those with things like this. So maybe we've reached out to someone who's listening now who's gone, oh, okay, I just didn't understand, or I didn't know that things were this bad. And then maybe we're making that effort. And that's all we can really hope for. So we chip away with our educational programs, with our university lectures, with our blog posts, with our radio interviews, with our TV appearances. Show people what's happening. Teach people what's happening. Teach people how we can do things differently. That's an important part. We don't want to stop people going from A to B, but we want people to go from A to B in a more sustainable manner.
Yeah, I think that. Yeah, so I think it's very good for people, anybody really, to be aware of that. Actually, because I must say, I wasn't aware that was that high. That kind of percentage of people who, who don't seem to be too fussed about it. So I think it's important for anyone to realise that that's the case. So thank you for dropping that term, value action gap. I think that's a good term for some people to kind of understand, isn't it? Be aware that that's the case, and just feed that into your own kind of personal efforts. I think, Yeah,
because nature's fascinating, and I would challenge anybody to look out and go, oh yeah, I don't really care about nature, because I'm sure they do, and I'm sure they're influenced by it, but maybe they just don't know by how much. So they like those birds coming to their feeder, but they don't really think about it on top of that. But if those birds fall silent and nothing comes to your yard, you'll soon know about it. Same with the insects. Like how many people like almonds, for example? Yeah. I imagine most people like almonds, or even almond milk is obviously quite traditional now, or quite trendy. Without our dear little honeybee, there will be no almonds. Honeybees pollinate 100% of almond trees. So it's little things like that where you could draw these connections, and there's thousands of these connections, and you can really start to see what happens. There's another, just to sort of finish on, there's another sort of adage. If we drop dead, the human race drop dead tonight, the vast majority of the wildlife wouldn't even blink an eye. They wouldn't even notice. But if our insects drop dead overnight, the whole world would collapse. That's an amazing fact to finish on, isn't it? I mean, that just straight away shows their value, doesn't it? Mental. Yeah, it's staggering, and you can't even express that. You can't put it into context. It would just be catastrophic. There's already lots of evidence of people where species X, insect X, has died out, and people are having to go around and pollinate specific plants and trees even with paintbrushes and things to maintain it. Obviously, that's not a sustainable thing. So nature does so many things for us. So much of our economy is based on nature that to counter it, or to find an artificial alternative to what nature provides, is going to be staggering. And we're already struggling with everything. Our prices going through the roof, and so on and so forth. This is nothing. We've just come through COVID, or we're still in COVID. If we won't get into that, but the COVID wave is only a sort of pinprick into the wave that we're going to experience with the impacts of climate change, and then more importantly, the impacts of biodiversity loss. And I don't think the human race and the majority of the people out there are actually ready and aware for what's happening.
Yeah.
Or what's coming.
It's funny, isn't it? I mean, it's a shame there aren't more films. You can have disaster films. It's always some kind of big dramatic, I don't know, earthquake or tidal wave or something. Well, how about a film about just the insects dying out, and then everyone's dying anyway now. I think it's just reframing it, isn't it, as thinking about, you know, truly the consequences of these things happening just sound absolutely immense. And as you say, people probably don't really realise. They're probably expecting, oh no, the world could only end for us if, I don't know, we get hit by an asteroid or something. But actually, well, what about if the insects die?
Yeah. Well, many will say, oh, I'm scaremongering or anything along those lines. And I really don't think I am. We don't know. This is the difficulty. We only have one planet. Yes. And so we can't say what will happen without humans, or what state we would be in if we didn't have humans on the planet now. Would we be in a better state? Would we naturally be going through these cycles of climate change and species loss anyway? That's some of the arguments which people push, who are sort of climate change deniers and things like that. And we can use models to explore what would happen and what wouldn't happen. And there's a lot of evidence to obviously say that humans are doing all this. But you can sometimes see where some of the climate change deniers are coming from. And I find that also quite interesting and fascinating to try and tackle that and deal with that.
Yeah, kind of understand the motivations and why they kind of come to those conclusions. Yeah, I think it's...
Yeah, I met like a sort of final case study. I went to a vineyard, a British vineyard, and it was run and owned by a particularly clever chap who was a very interesting, let's say, farmer. I don't know what the true term for a vineyard owner is, but he understood his grapes, he understood his vines, obviously, and he knew the local area, the local weather patterns, the geography, the geology, and so on and so forth. And he understood that climate was changing, and he understood that he could grow different species than he could 5 years ago or 10 years ago. And different diseases were around, and so on and so forth. And then I sort of pushed him on the fact and said, "Oh, so it's nice for you to sort of highlight the impacts of climate change." He was like, "Oh, no, well, yeah, but it's not human-induced climate change." And I was like, "What?" Okay. And he was one of the first people I met who was saying that climate change had nothing to do with humans. And he was a clever chap. He was a very good businessman. And it just sort of knocked me back a little bit because I hadn't really thought about it and I hadn't really prepared to have that sort of debate or discussion, because in my world, it's a given. It's automatically presumed that everybody knows that climate change is driven by us, by humans. But there are still many people out there who disbelieve it. And therefore, that's where that 70% comes in, because they don't think that them having 3 cars and driving all over the shop instead of using renewable energy or anything along those lines is something to worry about. They just crack on.
Yeah.
And that's about it, really.
Yeah, well, could do what we can do, right? I mean, you can carry on, pushing the education, which you're doing a fantastic job of. So let's hope that the people like that do actually decide to I guess, go away and get inspired and kind of think about nature and enjoy it and want to protect it and want to understand it. Because I mean, I think a lot of what you've been saying today, to be honest, is kind of all about that, the kind of value of doing that. Of I think you started off actually by talking about the kind of microbiome and likening it to, looking at these kind of really big charismatic animals and going and putting them under the microscope and zooming down and having a look at the microbiome and all those interactions. To me, it's kind of a bit of a story about, hopefully people can look at whatever it is that they think is particularly nice, use the example of the birds visiting the garden, and then they just start to think more and more about all those interactions and everything and go down that kind of rabbit hole of understanding more and more about nature. And I really hope that's the case, and I really hope, people do go away and do that. And I'm sure they must be doing that, because, you do deliver some fantastic and really inspirational work, which I really do thank you for coming on the show to talk about, Michael. It's been absolutely brilliant having you again. And I must say, can we grab you again for a future appearance? Would that be a possibility?
Yeah. I just sort of wanted to end on 2 things that my parents asked me, and they say, So why have you had a kid in this current world? And what's the point in what you do? If I believe that we are as sort of doomed as we are at the moment, and they're two very tough questions, and it's two questions which I've thought about a lot. So we'll tackle the child one first. So I've always wanted children, and I did and ah about whether we should be bringing a child into the world in today's day and age, with war plaguing, with plagues plaguing, and with climate change here and knocking out our species. It doesn't look bright. But what I wanted, Isaac, my son, is I wanted to offer him as much opportunities as I can to do whatever he wants to do, and educate him in as much as I can, and show him the different viewpoints and the different how different people think, and different religions, and all these different aspects. These are all things which I've looked for and found personally, and it was picking and choosing and finding out all these bits of information to understand what was going on at any one point of time, and I hope that he will take this, embrace it, and move on to the next big thing. So he might have one of the answers to how we tackle one of our big problems in life. And it's the same with the education side of things. Is the biggest impact I have is training and educating hundreds of students every year, and telling them and showing them really interesting things, but also hopefully inspiring those to actually make a massive difference. And it is this next generation who are going to be doing exactly this.
I think that's an absolutely fantastic message to close up on today. Professor Michael Sweet from the University of Derby, thank you very much indeed for joining us on Monster Frequency. I do urge you to go ahead and check out a bit more of his research. One of the really convenient places you can do that is on Twitter, actually. He tweets from the handle @DiseaseMatters. So he chats about all the kind of things that's going on in his lab, in his research, and everything basically that's occurring to him. So yeah, do go ahead and have a look at that. And I'll just close, I think, by wishing you a happy and productive Earth Day 2022. Stay tuned for more episodes of Monster Frequency that will be coming at you very, very soon indeed. But it's a goodbye for now. Bye!